Myself Pushkal Kumar Shukla, Assistant Professor at AKGEC Margari Engineering College in Computer Science Department. Today I will discuss function and growth of the function. This is a very important topic for the BTech third semester CSC students. The content which I am going to cover are definition of the function, classification of the function, operation on function, growth of the function. The objective of this topic is students will able to understand the composition of algorithm and floor or ceiling function to solve problems, give complete or a partial arrow diagram for the iterative function, and they are also able to understand the composition, operation on the function and growth of the functions. The prerequisite is basic understanding of the class 10 mathematics and CLT and basic understanding of set theory and relation. A function, what is function? Let A and B are the two sets, then a function f defined from A to B is each element of set A has one and one image in set B. It means ki a function f defined on set A and set B is each element of set A is associated with the element of set B, and second condition is each element of set A has one and one, yani unique image in set B. Domain of a function. Let f be a function from P to Q, then set P is called the domain of the function P. Then set P is called the domain of the function P. Codomain of a function. Let f be a function from P to Q, then Q is called the codomain of the function f. Range of the function. The range of the function is the set of the picture of its domain. In other words, we can say it is the subset of the codomain. It is denoted as f. Yani ki range, we can say ki range is a subset of codomain. In this figure, let A and B are the two sets and the function f from set A to set B. Then domain of this function is 1, 2, 3, 4, 5. All the element of the set A is the domain. So, domain of function, domain of f equal to 1, 2, 3, 4 and 5. If we are talking about the codomain, so codomain is the element of set B. So, codomain of f equal to A, B, C, D, E. If we are talking about the range of the function, range of f equal to all the elements of this set B which having the pre-image in the element of set A. So, here A, B, C, D, E all the elements having the pre-image in the element of set A. So, the range of this is A, B, C, D, E. Here we can see the range may be equal to codomain, yeah, it may be having a smaller than the codomain. So, we can conclude range is the subset of codomain. Type of the function, classification types of the function. First one is injective function. This is also known as a one-to-one function. A function in which one element of the domain set is connected to one element of the codomain set. Here we see one element of set A is connected with the one element of set B. A is connected with 4, C is connected with 2, B is connected with 5 and D is connected with 6. So, this is the function, this is the injective function, one-to-one function. It means one element of set A, one element of this codomain is connected with one element of domain is connected with one element of codomain. So, this is a one-to-one function. Here we see one-to-one correspondence between the domain and the codomain. So, this is an injective function. A function to be injective, this is very important. A function is said to be injective. We assume f(x1) equal to fx2, this imply x1 equal to x2. The condition to be a function injective, this condition must be satisfied. Yeah, we can say if x1 equal to not x2, this imply fx1 equal to not fx2. So, how to check the particular function is injective or not? For example, suppose a function fx equal to given as 3x square plus 2. We have to check this function is injective or not. So, first we assume fx1 equal to fx2. So, we assume fx1 equal to fx2. This imply 3x1 square plus 2 equal to 3x2 square plus 2. This imply 3x1 square equal to 3x2 square. This imply x1 square equal to x2 square. This imply x1 equal to plus minus x2. So, here we see x1 equal to not x2, but x1 equal to plus minus x2. So, therefore, it is not a one-to-one या onto function. Again, see another example. So, fx equal to 3x plus 2. So, here we see fx1 equal to fx2. So, this will be 3x1 cube plus 2 equal to 3x2 cube plus 2. This is cancel out. This imply 3x1 cube equal to 3x2 cube. It means here x1 equal to x2. So, this type of function is an injective function. So, injective function like fx1 equal to 3 के power x plus 2, 3 के power x cube plus 2, 3 के power x5 plus 2, 3 के power x7 plus 2. All these are the injective function. If the power of x is even, like fx equal to 3x square plus 2, 3x square plus 3x4 plus 2, 3x6 plus 2. So, all this type of function is not injective function because it will give you a x1 equal to plus minus x2. So, the condition is not going to satisfy here, therefore, it is not an injective function. Now, surjective function onto function. A function in which every element of codomain set has at least one preimage. So, here we see element of set B is A, B and C, and every element of set B has at least one preimage. So, A has preimage 2, B has 1, C has 2 preimage 3 and 4. So, a function in which every element of codomain set has at least one preimage, then it is said to be surjective function या onto function. So, for example, how to check the particular function is onto function or not? For example, suppose fx equal to 3x square plus 2 and x is element of R and this function is from R to R. So, how to check? So, y equal to, we take y equal to 3x square plus 2 to check onto function. To check surjectivity, we assume y equal to 3x square plus 2. So, 3x square equal to y minus 2, 3x or x square equal to y minus 2 by 3. So, x equal to root y minus 2 by 3. So, if we take y is the element of R, real value. So, real value minus 2 something, this will be a this will be real, it may be and this value is coming, it may be like positive, it may be a negative. So, divide by 3 and if you are taking root, so some cases it will give you a real value and some cases it will give you an imaginary value. So, for example, if y is suppose 7, so 7 minus 2 divide by 3. So, 7 minus that is 4 by 3 and 4 by 3 is 1.33 and that is root of 1.33, that is coming approx 1.1 approx. Okay, so 1.1 approx, that is also x is 1.1 is a real value. So in this case it's okay, but if you take y equal to, because y is a real value, so y equal to negative -3, so -3 minus 2, that is -5, -5 by 3, it will be coming minus 1.67, and root of minus 1.67, it will give an imaginary value. So here all the value of y has not pre-image in x, because it gives you a imaginary value. So for this it is not a onto function, right? So this is the way of finding the particular function is surjective function or not. Bijective, it is 1 and onto function. A function which is both injective 1 to 1 and onto, yani surjective, is called a bijective function. Here the element of set P is 1 to 1, x is associated with A, y is associated with B, and z is associated with x, and all the element of set Q have pre-image in the element of set P. So this is a 1 onto. So this is a bijective function. So for example, if you take y equal to 3x plus 2, so check this is a injective function, yeah, an onto function or not, this is a bijective function or not. So earlier we have seen, yeah, for injective we have to show fx1 equal to fx2. So 3x1 plus 2 equal to 3x2 plus 2. So here 3x1 equal to 3x2 and x1 equal to x2. So this is a 1 function. And for onto y equal to 3x plus 2, and the function is from, suppose, R to R. So 3x equal to y minus 2 and x equal to y minus 2 by 3. So for all value of y, it is to be real, it is a real. So real minus 2 divided by 3, it gives a real value for all value of y. So this is a, yani ki all the element of this having a pre-image in the element of set P. So this is a onto function. So it is both 1 and onto, therefore it is a bijective function. So y equal to 3x plus 2 is a bijective function. Into function, a function in which there must be an element of codomain y does not have a pre-image in the domain x. Here we see A and B are the two sets, and the function f associated from set A to set B. Here the element of this codomain, element of set B having no pre-image in the element of set A, so therefore it is called into function. A function in which there must be at least one element in set B which has no pre-image in the element of set A, so therefore it is a into function. Therefore it is a into function. 1 into function. Next type is, let f x to y is a function, then function f is called 1 into function if different element of x have a different unique image of y. Yani 1 and into function, yani every element of set x has 1-to-1 correspondence with the element of set y, and there must be at least one element in set y which has no pre-image in the element of set x. So this is 1 into function. Many one function. Let f x to y is a function. The function f is said to be many one function if there exist two or more than two different element in x, two or more than two element. Here see, two elements of this set x has associated with one element of, three element of set A x has associated with one element of set y. So this is the case of many one function. It means the function f is said to be many one function if there exists two or more than two different element of x having same image in y. Many one function, then many one into function. Let f is a function from x to y, the function f is called many one into function if and only if it is both many one and into function. It means that there must be at least two or more than two elements in x which have a same image in y, and there must be at least one element in y which has no pre-image in the element of set x. So, here see two having elements, two are the elements which have no pre-image in the element of set x. So, this is a onto and many one. So, many one into function, sorry, into and many one. So, many one into function. So, function is said to be many one into function if and only if it is many one and also into. Many one unto function. Let f x to y, the function f is called many one unto function if and only if it is both many one and unto function. Operation on function. As usual, operation with function, that is add function. Suppose there is a function f x equal to 4x minus 5 and g x equal to 2x. So, simple add function we apply f x plus g x. Yeah, we can write also f plus g x, that is simply 4x minus 5 plus 2x, simply add, then it is coming 6x minus 5. Subtract, suppose f x equal to 4x minus 5 and g x equal to 2x, then subtraction of the function f minus g x, yani f x minus g x, yani if f x is 4x minus 5 and g x is 2x minus 2x, then it is coming 2x minus 5. Again multiply function, let f x equal to 4x minus 5 and g x equal to 2x. So, f multiply g x written as f dot g x, yani f x dot g x, yani ki 4x minus 5 into 2x, and this is 8x square minus 10x. So, this is multiplication function. Then divide function, let f x equal to 4x minus 5 and g x equal to 2x. So, simply we write f x by g x, this is the division operation. So, 4x minus 5 divided by 2x. There is also one important operation, that is composition of the function. So, we will see later composition of the function. Then inverse function, let f be a function from a to b, then the inverse of f denoted as f inverse is the function from b to a, defined as f inverse y equal to x if only if f x equal to y. For example, we see, suppose this is the set x and this is the set y, and there is a function. So, this is x and this is element y. So, we can write here y equal to f x, and there is, if we see f inverse. So, f inverse is a mapping from y to x. So, y to x. So, f inverse x equal to y. So, y equal to f inverse, we see here y equal to f inverse x, like this, x equal to f, y equal to f x, and sorry, and x equal to f inverse y, sorry, x equal to f inverse y. And this inverse is possible if the function is bijective function 1, 1 and 2. To be a inverse, to find out the inverse of the function, first the function should be bijective 1, 1 and onto. So, this is the important condition. No inverse exists unless if it is bijective. For example, let f x equal to x square, f x equal to x square, and the function is from real to real. So, if f invertible, so first of all we have to check it is 1 1 and onto or not. So fx equal to x square, x1 fx1 equal to fx2, what we will do here, fx1 equal to fx2. So x1 equal to square equal to x2 square, and this equal to x1 equal to plus minus x2. So this is not 1 1, so inverse is not possible. So is f invertible? No. And if so, what is the inverse? So not possible in this case. Thank you.